If it's long, I can stay. I can start.
Well, that's the longest. Yes.
If it's long, I can stay. I can start.
Well, that's the longest. Yes. Okay. Okay. All right. Good morning, everyone. It's a great pleasure to host Savvas today, who's visiting us from Delft. So Savvas is a assistant professor at Delft. Before Delft, he was at MPI, and before he did his PhD in Cyprus, and he's done a lot of work on cyber safety, online harms, and had multiple papers at ICWSM, IMC, best paper awards here and there. So it's really, really great to host him here. Without further ado, Savvas, take it away. Thank you.
Thanks a lot for the introduction, Emiliano. So good morning, everyone. I'm really excited to be here with you today to talk about, to talk basically about my research that focuses on understanding self-moderation interventions on the web. So if you don't understand what is self-moderation interventions, don't worry, I will explain everything as we go. So a short agenda for the talk today. So I will start with the brief motivation and overview of content moderation systems and why they are important. And then for the rest of the presentation, I will just talk about two recent research papers that we did. The first one is about understanding how these self-moderation interventions are used on Twitter during the 2020 US elections. And the second one is focusing on the TikTok platform and specifically on videos related to COVID-19. So I will start with a small introduction of my work. So basically, what we are doing, we are essentially studying the web ecosystem to understand the emerging societal issues that exist on the web. So if we see this, modern web ecosystem, we can see a lot of web communities that are interconnected together. Is the finger on the top?
Huh?
Okay.
Yeah, no, it will hide myself.
Okay.
Or you just move the mouse.
Okay. So yes, so we are studying this web ecosystem mainly because on the one hand, it's pretty great, right? Because this web ecosystem allows us to it basically allows us to improve our lives. It addresses a lot of our needs, like our communication needs. It helps us, acquire knowledge and also do other cool stuff like shopping and entertainment, right? So imagine how our lives will be during the COVID-19 pandemic without all these, social media platforms and all these tools that this ecosystem provide us. However, with most things in life, let's say, there are two sides of the same coin. So basically, the same modern web ecosystem can also have some drawbacks. For example, it amplifies emerging problems like the spread of means of disinformation, spread of hateful content, and we also have a lot of manipulation and so on. So it's important to study this ecosystem and design effective interventions to basically mitigate these problems. And how do we do that? So we do that basically through content moderation, right? So what is content moderation? Basically, content moderation is a procedure that basically The main goal is that it ensures that the platform is used as its creator intended, and it protects users from exposure to potentially harmful content. And how it works is that each platform has its own content moderation system, which is basically a complex and multi-layer system, mainly because it combines both automated techniques, for example, artificial intelligence, along with human moderators to detect basically problematic content and remove it from the platform, thus protecting the users. So I mentioned that the content moderation systems are multi-layer and complex. So here I will provide a small overview of these various interventions that exist within these moderation systems. So essentially, we can think of these interventions happening in 3 levels. So we have the post level, meaning it happening, we moderate stuff based on specific posts. We have the user level interventions, which means we moderate things on a user level. For example, if we have some problematic users, then we can either ban them or remove them from our platform. And we also have the notion of community level intervention, meaning that we have, within the same platform, we have these communities of users, and then you can moderate things on a community level. For example, if we consider one of the most popular media platforms like Reddit, a community there is a subreddit. And for all 3 levels of interventions, we have 2 different types of interventions. We have hard moderation interventions and soft moderation interventions. So the distinction here is that hard moderation interventions basically remove content from the platform, so other users cannot see it at all. On the other hand, soft moderation interventions basically aim to not remove content from the platform, but inform the users about the nature of the content. For example, if it shares something that is harmful or likely, a bit misinformative, then we can inform the users and let them make the final decision if they want to consume or engage with this content. So to give some examples about these interventions. So for the post level, we have, hard intervention, which is basically a post removal, meaning that in tweet, we can delete a tweet. And we also have soft interventions like these warning labels that Twitter started using. For example, this is one of the most prominent examples. You see there Donald Trump sharing a piece of misinformation, and then Twitter added this warning label to inform the users about what was the actual outcome of the US elections. So let's move to user level interventions. Here again, we have user bans, which is essentially hard interventions because we remove specific users from the platform, and we also have these soft moderation interventions, which is basically the shadow ban. So shadow ban is basically a method that is employed by social media platforms where you decrease the visibility of content that is shared from specific users because they are either trolling or they behave not good. So you don't remove the content, but you decrease the visibility within the platform.
So nobody sees it, or just fewer people?
We have multiple levels of shadow banning. For example, on Twitter, you also have these things that are, for example, in the replies, you might have this show more, right? So which basically you can see the content, but the users have to explicitly make some actions to view it, so you cannot see it by default. So this is one of the ways that they do it. The other way is basically they make sure that the content doesn't appear within search results or something. And finally, for the community level interventions, we have something similar with the other levels. For example, on top here, I show an example of a community that got banned from Reddit, which means that it got completely removed from the platform. And what it means, I want here to clarify something. So when a community is banned, the users that are part of it aren't banned. They can continue posting in the platform on other communities. but they cannot post in that specific community because it's banned. And for soft moderation interventions, again, we have these, community level warning labels like the one shown in this slide, which basically, inform the users that, this community shares a lot of highly offensive content, and users can opt in to continue and see the content nevertheless. Yeah. So any questions about thus far? About anything that is not clear? Okay, cool. Okay, for the purpose of this talk, so I will just focus on analyzing post-level interventions, specifically soft moderation interventions. So for the first part, I will talk about the first paper that basically focuses on Twitter, and then I will continue for the study on TikTok. Again, very briefly, what are soft moderation interventions? So in this study, we consider a soft moderation intervention as the warning labels that are added below a tweet. So again, they aim to inform the users about the content without removing the actual content. So why do we care? So
slides are not moving. I don't know why.
Okay.
Maybe I just. Since I installed that thing downstairs, it broke everything. So. Okay. Hopefully it works.
Okay. Okay, let's continue. So why do we care about soft moderation interventions? So we care because these types of moderation interventions have started to becoming increasingly popular on social media platforms to tackle, misinformation related to health as well as politics related misinformation. And the good thing about these kind of soft moderation interventions is that they can essentially ease public concerns about suppression of free speech, right? So because you don't remove the actual content, then you ease some concerns about people Twitter is censoring us and all these things. As I said, we use it because they are basically used by mainstream platforms. Specifically over the past few years, these interventions are used by Twitter, Facebook, and TikTok. In this work, we basically perform the first empirical characterization of these types of warning labels, meaning that we study how these things are used on Twitter in the wild. So because nobody looked into it from an empirical perspective, we wanted to understand, the various types of warning labels and users that share content that eventually gets warning. So what engagement does content with warning labels receives, and specifically how it compares to content without warning labels. So here we wanted to basically understand if, problematic content that eventually gets warnings receive less engagement. And finally, we wanted to understand how users interact with warning labels or the content that gets warnings. So what we did here is that we perform a large-scale data collection where you use Twitter API to collect recent activity from Twitter users. So here we focus on verified users. So verified users are basically users on Twitter that have a large audience. And we elected to, to focus on verified users just to limit the scope of the study. So what we did is that we obtained a list from Pushshift that includes a list of verified users from Twitter, and then we sorted this list based on the number of followers. And we obtained the top 48%, mainly because of limits on the API. And basically what we did for each user, we collected their most recent activity, which is basically a few thousand tweets. It's basically the last few thousand tweets that the user posted. So overall, we collected 79 million tweets from 168 users. So all the tweets were shared during 2020. And for each tweet, basically, we also extracted the tweets that had actual warning labels. And so here it's also worth noting that most of the collected tweets are between November and December 2020. And this is mainly because of the time of the data collection. So because of the time of the tweets, which is basically between November and December, most of the things in this data set is related to the 2020 US elections. So looking into an overview of the data set, so we can easily observe that the problem of these warning labels, identify warning labels, is like a needle in a haystack, right? So we collected 79 million tweets, and only 2.2 thousand tweets had actually warning labels, and only 850 users share at least one tweet with a warning label. And here we also have this notion of, what we call the quoted dataset, which basically is divided into 3 parts. So the main idea here is that this dataset allows us to study how users interact with content or warning labels. And here I have an example of the quoted dataset. So here you can observe that we have this tweet, which is I won the election. We have this warning label, and then you have a comment above, which is basically a retweet with a comment that comments something about the tweet. So this example here falls in the first part, which is the warnings in the quoted tweet. So because you have multiple combinations, where is the warning label? For example, you might have warning labels on the comment above only, or you might have on both, right? So the table summarizes all the numbers. So let's start with, yes.
So sorry if you said it and I missed it. I was checking that the people could see it. So how did you get these tweets?
The actual tweets.
Yeah, how did you get this data set? So there is something in the API that.
Yes. So basically yes. So basically here I didn't provide all the details. So what it happens is that by default the official API does not return any data about the warning labels. So essentially what I did, I used another API that is used by the browser when a logged in account goes to the browser and checks a user. So essentially I called that API with an account, and then I collected the recent tweets. And because I'm calling that API, which is basically what the browser uses, I get a different JSON that has more information. So I know from that JSON which tweets that are visualized, that are provided, have the warning labels. So that's
your starting point is the 1%?
No, the starting point, I'm starting from a set of users, verified users from Pushshift, okay. And then for each user, I collected the recent tweets, right, based on this API.
I see. Okay.
Yeah. Yep. Okay, the first thing that I mentioned that we wanted to study is the different types of warning labels, right? So this table here summarizes the percentage of tweets that had the warning label. So here it's among the 2.2 thousand tweets. So 58% of these 2.2 thousand tweets had this claim about the election fraud is disputed. So overall, because also of the time of the data collection, most of the warning labels are about the US elections and claims about that. But we also, observe something that is more general purpose. For example, we had this manipulated media warning label, which means that when someone shares something on Twitter, like a video or an image that is manipulated in any way, Twitter puts this warning label. We also have a few warning labels that are actually about COVID-19. For example, get the facts about COVID-19. And another interesting thing here is that we also have warning labels that are multilingual. So here we have 2 warning labels that are written in Portuguese. And by translating these warning labels, they are basically about the 2020 US elections, but they are written in Portuguese, which I don't know why. And this is not because of how we collected the data. So because it doesn't take into account the language of the account. The language of the account was the same for everything. So that's it. Yeah. So here, given the fact that a lot of tweets are about the 2020 US election, so here what we wanted to understand is which users are sharing content that eventually gets warning labels. And so what we did here is that for each user in our dataset, we infer their political leaning using the approach by the paper that is presented by Kulsworth et al. at CSW 2017. So this approach, basically what it does is that for each user, it collects all the followers and the network of the user, basically. And then based on the followers, then it constructs a set of topics. And then based on ground truth data, it has a classifier that assigns a user as a Republican, Democrat, or neutral. And for some, small cases where a few people don't have a lot of connections or some accounts got deleted, the tool was unable to return an inferred political leaning. So the left side of the table shows the tweets with warning labels, which is basically the original tweets that had the warning labels, that received the warning labels. And the right part includes the quoted dataset. So the main finding here is that basically most of the tweets that actually receive warning labels were shared by Republicans, which kind of makes sense because Republicans were sharing more misinformation because they essentially lost the election, and also because Trump was also sharing a lot of misinformation. Whereas for the quoted tweets, which basically we find that 56% of the tweets in the quoted dataset was actually shared by Democrats, which also means that Democrats were taking, for example, tweets that were shared that had warning labels, and they were making comments. So that's why it. Yeah.
So you said that the classifier uses some ground truth dataset. Yes. So that's from 2017.
Yes, that's an old dataset. So because of that, and because we weren't sure how well it performs to our dataset, so we did our own validation, which basically we extracted a random set of users and we manually classified them on our own. And we observed that it had an 80% accuracy, which means that it's not perfect and there are a lot of misclassifications.
You did it yourself?
Yes.
Deliberately?
Yes.
No, because this is based on topics, right? This ground truth data set.
Yes.
So I would imagine that the topics shift quite a bit, right? So there's new things, I don't know, positions on Ukraine or some new refugees or something like that. But no,
just to clarify, do these numbers also include tweets that both the quoted tweet and the original tweet have been flagged as well? Is that
so? The quoted tweet includes all the three. But if you look into the numbers in the, you see the numbers. Most of the tweets are basically this thing, which is basically the warning is only on the quote. Yeah. Okay, so let's move on to the engagement analysis. So here, basically, we made the following hypothesis that we know people will be less willing to reshare or engage with content that has warning label. This is because if I tell someone, that this is, harmful or misinformative, then we expect that people will not share it more. So we basically, what we did to test this is that for each user, we extracted 2 sets. So the first set is tweets with warning labels, and then the second set is tweets without warning labels. And here I think we focus only on users that had at least at least 5 tweets with warning labels. And basically, what we did, we compared the distribution of means in the 2 sets for 4 engagement metrics. So the 4 engagement metrics are number of likes that the tweet received, retweets, quotes, and replies. So here are the results for likes and retweets. So the same pattern applies for the other engagement metrics, but I only keep these 2 here for brevity. So basically, the main finding here is that we actually find that tweets with warning labels basically have more, receive on average more likes or retweets compared to the tweets without warning labels, which basically it might be because of how Twitter's content moderation works. So what do they say is that they prioritize content that has a lot of engagement to basically moderate. So if they see something that is it's going viral, then they prioritize to moderate it, and that's why that's a likely explanation of why this is happening. And another limitation here in our analysis is that we don't know exactly the time of when the warning level was added. So we don't know if the content received a lot of engagement even before applying the warning label.
I have a question about the control set. So was it matched learning features to the warning labels, or was it just like a random subset of?
No, it was random. Yes, it was random. No. Yeah, that's a good point, by the way, because because we don't match the same topic, then it might be that the one topic is more viral than that. Yes. But it was completely random. Yeah, and for the final part of this first part, so I would like to share some findings from our analysis of how users interact with content or warning labels. So what we did here is that we basically we used the quoted dataset and extracted 3 sets of tweets that we qualitatively analyzed. So specifically, we extracted the 50 tweets where both tweets had warning labels, all 169 tweets that had a comment above that had the warning label, and a random sample of 150 tweets where the warning label was on the tweet below. And then in the next few slides, I will share the main findings. So let's start with the cases where the warning was both on the comment and the quoted tweet. So when basically 86% of the cases that we qualitatively analyzed was basically tweets above, the comment above was essentially reinforcing the false claim that was included in the quoted. And interestingly, for some of the comments, there were even tweets with a single word. For example, hashtag stop the steal, and it was for that case it was even still moderated. So which means that Twitter consider also the content on the quoted tweet. So we found some instances where basically users were testing if their comment will get flagged. So basically what happens is that they get a tweet that has flags, and then they try to comment above with the same, let's say, content and see if their comment will get flagged. And we also found some interesting cases of incorrect additions on warning level. For example, the example that I have here. So this tweet says, post anything random about oxygen and frequency, and Twitter slaps a weird editorial note on your post. And he writes something there, and he received the warning label "Get the facts about COVID-19," which is completely irrelevant. And then another guy, quotes the tweet and writes something about oxygen and frequency, and again it gets the same warning label, which doesn't make any sense. So here I suspect that they use some sort of automated system that doesn't perform as well. So let's move on to the cases where the warning was on the comment about the coded tweet. So we find that 36% of the tweets that we analyzed was basically commenting on news and real world events, and they were making false claims about the elections. We found 14% of the cases where they basically they were responsive bad content. They make it even more questionable or harmful, thus receiving a warning label. And we also found a substantial percentage of tweets that basically had inconsistencies on the addition of warning labels. So, for example, we find instances where both tweets hint to election fraud, yet only the comment above gets flagged. We also found instances where we have the same type of information that is shared across different information formats. For example, you have a tweet that shares the same thing in video with a tweet that is shared the same thing on text, and only the text tweet is getting moderated. And we also found issues across languages. For example, the one that I showed here. So basically, this example here disseminates exactly the same information. The comment below is in French. The comment above is in English, and only the English one gets moderated. And finally, we analyze the cases where the warning is on coded tweet only. So we found a lot of cases, 24%, where they mock the content or the author of the tweet. And this is mainly because Donald Trump is our superstar in our dataset, which basically we have a lot of tweets from him. And then people are mocking Trump because he says things that get warning labels. We found cases where they were basically debunking false claims. So they comment above and they say this is false. We found 4% of the cases reinforcing false claims, but the comment didn't have a warning label. And we also find a small number of tweets that basically they share opinion on the warning labels themselves. For example, I have an example here where basically one user calls Jack, which was the CEO of Twitter, and tell him to basically ban Trump because of these lies, and saying that warning labels are not sufficient.
Sorry. How do you classify this manually, or you?
Yes, manually. By qualitatively looking into the tweets. Okay. So to summarize, for the first part, so we asked how warning labels are used on Twitter. So what we found out is that most tweets with warning labels are shared by Republicans during the 2020 US elections. We found out that tweets with warning labels tend to have more engagement, again with the limitations that I mentioned. And we also investigated the various types of interactions with content and warning labels. And we found that we highlight several challenges and inconsistencies that exist on this large-scale soft moderation system. So the dataset collected in this work is publicly available. So if you want to do something on this space, feel free to use it. Any further questions thus far?
I have one.
Yeah.
So I know that wasn't the focus of your work, but so what about effectiveness?
Effectiveness.
Can you chime in on the effectiveness of this soft moderation approach? But like specifically, let's say for the election day.
Yes.
Right. The labels and the warnings. So do you have any insight on the effectiveness, let's say?
So for the effectiveness, I didn't really look into it, but I wanted to do something about it to basically understand the effectiveness. What I wanted to try was to essentially see how the engagement of content changes over time and where exactly the moderation happened, right? So what I tried to do after this work was to basically monitor a small set of users continuously, meaning that every 10 minutes, go and check get the recent activity. And by doing that, I will know around the time the warning label was added, right? But I didn't pursue it more because I didn't get a lot of data. What had happened is that after the 2020 US election, Twitter banned a lot of people. So the people that were a lot of
compounds, right?
yes. So I had only a small number of samples. And the other interesting thing that I noticed is that after the elections, Twitter became more strict, meaning that yes, they added the warning label, but they also were restricting the ability of other users to retweet and reply. So when I was collecting this data, you will see, for example, for each tweet, the number of retweets increasing over time, right? Because it's cumulative, and then after a warning label, it goes to zero, you know, because there's no ability to so it was going to zero. So yeah, I didn't pursue it more because I didn't have more samples, but I had the same idea to study the effectiveness by looking into the engagement over time before and after.
I thought as well.
Yes, but it's a bit tricky to collect data.
No, we should talk.
Yes.
Yeah, I have another question. So when you were manually checking the tweets, did you find any instances where the interventions actually had any pushback? So for example, you know, Twitter says this is false, so it must be true, and they're trying to hide it, kind of thing.
Can you give me an example?
Yeah, I mean, so, you know, we see that a lot with fact checking sometimes. So, you know, a fact checker publishes an article, and then the people that want to believe the misinformation are like, you know, the fact checkers are probably working for some shadow government or something. So, you know, they're just trying to, you know, deceive us. So did you see any examples of that kind of thing? Like people looking at these labels and then just pushing back against them and saying that, you know, something else going on?
I don't remember any specific instances, but I suspect that it's likely to be happening, but I don't remember specific instances with that. Yeah. Okay. So let's move to the second part. So basically, the problem of misinformation is not only limited to politics. So during the last few years, we have also a lot of misinformation related to COVID-19. And so we wanted to understand how soft moderation interventions are used on health-related information. And in the second part of this talk, I will present our work that aims to study this issue through the lens of TikTok. So let me give a brief overview of what is TikTok. So TikTok is basically a user-generated video sharing platform. So a user can create short videos, usually around 15 seconds, and they share it on the platform. And recently, TikTok increased the maximum video length to 10 minutes, by the way. But most of the videos are usually short compared to other platforms like YouTube. And basically, how it works is that the user logins to the mobile app, and he basically receives an endless stream of algorithmic recommendations. So you continuously scroll on the platform, you get new videos to watch. And basically, TikTok is unique in a sense that most of the videos views are because of recommendations, essentially, which is a far bigger percentage compared to all the other video platforms out there. And the other things that users can do with TikTok is that they can follow TikTok accounts. They can also interact with videos by liking, sharing, etc. So why do we care about TikTok? We care about TikTok because essentially it's becoming extremely popular. It even surpassed Google and Facebook as the world's most popular web domain. And we also are interested in TikTok because a lot of anecdotal evidence emerged where they show that, you know, this algorithm can drag people into harmful rabbit holes. And we wanted to understand how this platform works. So our focus here is to basically understand COVID-19 related videos on TikTok and TikTok's efforts to moderate content using soft moderation interventions. So we wanted to understand how does TikTok applies warning labels, and what is the content of the videos that have warning labels. So again, some basics about the data collection. So what we did here is that we started with 2 specific hashtags, so hashtag coronavirus and hashtag vaccine, and we collected all the videos that include these videos using by scraping TikTok's website. So by scraping the website, we only get a few thousands of tweets sorted according to their popularity based on TikTok's algorithm. And basically what we did later on, we basically expanded our hashtag sets by looking at the hashtag appearance on the video and descriptions that we already collected on. And basically at the end, we ended up with a set of 26 COVID-related hashtags and collected an overall of 41,000 TikTok videos. And then we basically used we scraped the website to collect additional data about each video, such as the number of likes and so on, along with information on whether the videos had warning labels. So our approach here is similar to the previous one. So we perform a mixed method analysis. So basically we perform quantitative analysis on the entire data set and as a small scale qualitative analysis where we'll produce a code book and then we code 222 videos. So I will give more details later on. So here it's a similar table with what we used before for Twitter, but the results are completely different here. So the main thing here is that we collected 41,000 TikTok videos and 46% of all the videos that we collected had a warning label, which it's a different thing than what we looked into on Twitter. And we find out that most of the warning labels are about vaccines, so to 29%, and around 60% had this general warning about, learn the facts about COVID-19. And interestingly, we also find these, these warning labels that are basically unrelated to COVID-19. So this video could result in serious injury, and this content may not be suitable for some viewers. And based on this, basic statistics, we started thinking that we might have also content that is not related to COVID-19 because of these warning labels. So then we looked a bit into the prevalence of warning labels per hashtag. So this plot here shows for each hashtag, what is the percentage of videos that had warning labels. So you can see that we have around 20% of the hashtags have around 100%, which essentially means that every video that has, for example, hashtag coronavirus, then it gets a warning label, right? Respectively of what is the content of the video. So what it happens here is that they basically we think that they apply the warning labels based on the hashtags themselves, which is pretty bad, as we will gonna see later on. Yes, so here we did something similar with the previous study where we wanted to study the engagement. So here we separated, basically we find a different result compared to the previous study, because we found out that basically things without warning labels had in general more engagement, but we also found out this difference between the warning labels. For example, if you compare the blue line with the yellow line, you have a huge difference based on the type of warning label. For example, COVID-19 warning label had substantially larger engagement, which we don't really understand why this is happening. It might be because COVID-19 only things are more popular in general compared to vaccine-related stuff on TikTok, but we don't have any more insights on this. Yeah, and
yes, it might be related to how popular are the accounts that.
Yes, it might,
but not necessarily because of the topic. It might be, I don't know, COVID-19 tweets from, I don't know.
Yes, basically the issue here is that because of our data collection, we are biased towards popular content because you search for a hashtag and then you get the most popular. So yeah.
Yeah, but again, it can be more or less popular.
Yeah. Okay. So for the second part, we basically for TikTok, because we are dealing with videos, it's a bit hard to automatically analyze the videos. So what we did here is that we wanted to do qualitative analysis on the videos. So what we did, we extracted a random sample of 500 videos. And then for the first stage, we had two authors annotate the videos as related or not related to COVID-19. And why we do that? Because we saw some preliminary videos and we see that a lot of things weren't related to COVID, despite the fact that they include COVID-19 related datasets, hashtags. So from here, from this annotation, we excluded 129 videos that are not in English because we weren't able to understand what we were talking about, and 6 videos that basically became unavailable, meaning that the videos were available by the time we collected the metadata, but when we tried to qualitatively analyze them, we didn't have the actual videos, so we had to move to TikTok. They were deleted. And the interesting thing here is that, so at the end, we ended up with 365 videos, and we found out that only 222 were actually related to COVID-19. And more worse is that the rest, 143 non-COVID-19 related videos, a large percentage, 23% of them had a COVID-19 warning label, which basically it's pretty bad because what is happening is that you have videos that are completely unrelated to COVID-19 and TikTok slaps a warning label about the COVID-19.
The posters of these videos used the hashtag, probably because it was popular at the time, so they make the video.
Yes. Because so we found a lot of videos where basically were unrelated videos. For example, a video about my cat, but because it was filmed during the coronavirus pandemic, they just put hashtag coronavirus, and then TikTok put the warning label.
That was automatic, similar with the oxygen and frequency before on Twitter.
We are not sure of how they apply it, but my feeling is that they use something automatic. Yes.
Okay. So, some of if you go back to your don't go back, but you're saying that only some of them have 100% right of the warning label. So a lot of the hashtags have much less. So they're applying it more selectively for other ones, or
basically because on TikTok they use a lot of hashtags. The same description, so it might have.
So you didn't separate out.
Yes.
Okay.
Yes. So we didn't see the hashtag occurrence there.
Yeah.
It might be because they include both coronavirus. Okay. And for the final, after collecting this set of 2022 COVID-19 related videos, we qualitatively analyze the videos, construct a codebook, and code them to understand their content. So basically here our codebook has 3 main categories. So the first is the video type. So we have these various codes about the type of the videos. For example, we have a lot of videos sharing personal news, for example, people getting infected, videos made for fun, informational videos, which is basically people trying to explain various things that happened during the COVID-19 pandemic, and opinion videos, which is basically someone sharing her opinion on a topic. We have the second category is basically stance towards various topics. So here we code if the video is pro, anti, or not applicable to various topics. So the topics that we focused on is washing hands, masks, social distancing, quarantine, and vaccine. And finally, we have this category, which is basically what we call suitability for warning labels. And here we assume that the video should have a warning label if it shares some kind of misinformation or harmful things. For example, sharing fake news about vaccines or COVID-19, or promoting some harmful things like promoting coughing to people, and so on. So in the next few slides, I will just share some of the main findings from this analysis after coding the entire dataset. So the main thing that we found by looking into the type and the suitability for warning labels is that we found that a lot of videos that try to provide information and be informational videos actually include misinformation. And the other thing that we find out is that basically a lot of videos that include misinformation are made for fun. So a lot of people try to entertain other people, but essentially their videos also include misinformation which might be harmful. Next, we looked into the topics and their stance. So basically what we found out is that basically the vaccine is the most controversial topic because you have a lot of the videos that are basically anti-stance and you have a lot of pro-stance. And what else we found is that basically we have also a lot of we found 5 videos that are actually anti-mask, but a lot of them were also pro-mask. And finally, I will share some thoughts about the placement of warning labels. So what we found out is that basically we have a substantial percentage of videos that actually do not share harmful content or misinformation, but include a warning label by TikTok. So 37% of the videos that we analyzed. And a prominent example in our dataset is basically a video shared by the World Health Organization. So aiming to raise awareness that young people can also get infected. So what it happened is that the World Health Organization shared a video saying that people be careful, even young people can get infected, and it still had the warning label, which to me doesn't make much sense because it doesn't share anything bad, it tries to raise awareness. And you also have a substantial percentage, so 7.7%, that basically videos share harmful content or misinformation and do not include the warning label. So a prominent example in our dataset is basically a video. Basically, there is a woman sitting on a couch, and the woman starts having spasms on the couch, and you see a text overlay saying that when you take the COVID-19 vaccine. So basically, I think it's a video made for fun, but they share misinformation and so on, and it doesn't include the warning label, which is pretty bad. So to summarize, from our analysis, we found out that TikTok follows basically broadly places warning labels on videos, likely based on the hashtags that they appear. So in my opinion, this is pretty bad because what it happens is that you have a large number of videos that have warning labels, and if people continuously see the warning labels, they will just ignore them, right? So especially if they are also added on videos that are unrelated to COVID-19. We found a substantial percentage of false positive, false negatives. We found also that made for fun videos can indeed also share misinformation, so people should be aware of this on TikTok. And to conclude, some recommendations or thoughts. So basically from both studies, we observed that Twitter and TikTok use mainly generic and ambiguous warning labels. So if you recall, for COVID-19, we have these very generic warning labels like get the facts about COVID-19, which doesn't give a lot of context to the user. So I think there is a need to have more fine-grained warning labels that give more context to the users. Their soft moderation systems are not perfect. We have a lot of false positive, false negative. We find a lot of inconsistencies across languages and formats. So to conclude, we need more specific and accurate systems to tackle the problem of misinformation on the web. And that's pretty much what I had for today. Thanks for your attention. I will take any further questions.
Stop the stream.